In this video, I'm going to introduce HiPIMS flood model, which is applied in the flood prepared project for flood simulation and forecasting. In general, there are two typical types of flood models: hydrological model and the hydrodynamic model. Hydrological model is usually for coarse resolution, broad scale, and long-term flood simulation. It only simulates the simplified physical process of flooding and requires a lot of empirical parameters which are estimated based on past events. However, in our project, we need to simulate flood in urban surface with very complicated topography, including buildings, roads, canals, and bridges. And due to climate change, we are facing more and more extreme events with higher speed and faster evolving process. Some of them are even unprecedented, which means the empirical parameters estimated before might not be working in the future, and therefore we need more physically based models. Hydrodynamic model is fully physically based. It is implemented on a grid of quadrate or triangular cells representing land surface. The physics and mathematics behind the model are shallow water equations that are derived from physical laws, including the conservation of mass and the conservation of momentum. The equation involves three variables: water depth, velocity in x direction, and velocity in y direction, which are the basic mechanical properties of water in motion. And the modeling process is to solve the equations in each time step at each grid cell to get the values of the three variables. However, to solve the equations needs a lot of computing, and that is why hydrodynamic model is usually applied in small scale, such as a flume in labs, a pond, or a segment of river. HiPIMS is developed to address this challenge and make hydrodynamic modeling more feasible in broader scales. The name of HiPIMS is short for High Performance Integrated Hydrodynamic Modeling System and has three main features, including its high spatial resolution, the state-of-art numerical methods, and most importantly, GPU acceleration. Hydrodynamic modeling requires parallel computing to solve equations in millions of cells. Traditional methods usually use CPU in calculation. However, architecturally, the CPU is composed of just a few cores with lots of cache memories that can just handle a few software threads at a time. In contrast, a GPU is composed of hundreds of cores that can handle thousands of threads simultaneously. So CPU likes a superhero for complicated problems, but GPU is an army for simultaneous working. Therefore, a GPU accelerated hydrodynamic model is much more effective than the CPU model in solving the flood simulation problems in a broader scale. HiPIMS needs topography data, land use data, and water sources data to run a simulation. And the water sources can be rainfall, river flow, or surge and tide height time series, depends on which type of floods we want to simulate. And the output of HiPIMS includes inundation depth and water velocity on all the grid cells within the domain and almost at any given time, because the time step is quite small. And we can also produce maximum inundation maps throughout an event. The HiPIMS flood model was calibrated in Newcastle with a very serious event happened in 2012. It's called Tomb Flood. The model domain covers Newcastle, Gateshead, North Tyneside, and South Tyneside with a total area of 400 square kilometers. And the resolution of the model is 2 meter, and which means it has 100 million cells. The speed was 2 hours to simulate the 6-hour event. This image is one simulated result from HiPIMS. It shows the maximum inundation depth in the northwest of the Newcastle University campus. We also compare the simulated results with flood photos taken by pedestrians during the event. The simulated results can match well with over 80% of the flood photos in different locations, which demonstrates that the HiPIMS model can accurately simulate floods in Newcastle, Gateshead, and Tyneside. That's all for the HiPIMS flood model. Thanks for watching, and please feel free to contact with me if you have any questions.